The probability density function is given by x plus r minus 1, r minus 1, probability of successes raised by x, and the probability of failures raised by r. To find the mean, E of x is equal to the summation from x equals to 0 to infinity, x times the probability density function for the negative binomial distribution. When we expand the next step, having 0 times the probability density function plus the summation of x is equals to 1 to infinity, and x times the negative binomial distribution. This gives us a 0, therefore we remain with the summation of from x is equals to 1 to infinity, x times the probability density function, where we further now the probability density function, considering this number in brackets a combination, then in the next step we have x plus r minus 1 into brackets factorial out of r minus 1 factorial, x plus r minus 1 minus r minus 1, whole thing into brackets factorial, probability of successes raised by x and probability of failures raised by r. Next step we have the summation of x is equals to 1 to infinity, x times we have x plus r minus 1 factorial out of r minus 1 factorial, x factorial, probability of successes raised by x, probability of failures raised by r. Next step we have the x's cancelling out, and then we shall remain with equation 1, which is the summation of x is equals to 1 to infinity, x plus r minus 1 factorial, x minus 1 factorial, r minus 1 factorial. But r out of r factorial is equals to 1 out of r minus 1 factorial, and 1 minus p, which is the probability of failure raised by r, is equals to 1 minus p, r plus 1 times 1 minus p to raise to the power negative 1. Substituting these equations into equation 1, then we shall have rp into r minus p raised by negative 1 summation of x is equals to 1 to infinity. Then we have x plus r minus 1 factorial out of r factorial, x minus 1 factorial, probability of successes raised by x minus 1, and probability of failures raised by r plus 1 as equation 2. Now, when we let w is equals to x minus 1, if x is equals to 1, and then w is equals to 0, and x is equals to w plus 1, then we also let s is equals to r plus 1, which further leads r into s minus 1. Substituting into this equation 2, then we shall have rp into 1 minus p raised by negative 1 summation of x from 0 to infinity brackets w plus s pause, with rp into 1 minus p raised by negative 1 summation of x is equals to 0 to infinity into brackets w plus s minus 1 into factorial out of s minus 1 factorial, w factorial times the probability of successes raised by w, probability of failure raised by s. For a negative binomial distribution, we shall have the summation starting from w is equals to 0 to infinity into w plus s minus 1 factorial out of s minus 1 factorial, w factorial times p raised by w, then 1 minus p raised by s, which will give us the summation of w is equals to 0 into infinity as p pause. For negative binomial distribution, For negative binomial distribution, the summation of w equals 0 to infinity, w plus s minus 1 factorial, s minus 1 factorial, w factorial times p raised by w, 1 minus p w raised by s will be equals to the PMF of w and s, which is equals to 1. Now substituting this into 3, rp into 1 minus p raised by negative r times 1. Therefore, the expected value of x, or the mean, will be equals to rp out of 1 minus p. Next, I want to show you how to find the variance of event. I'd like to show you how to find the variance of the negative binomial distribution. Variance, as you know it, is the expected value of x squared minus the mean squared. Variance of x will be equals to the expected value of x squared minus the mean, which we already found in the previous number as RP out of 1 minus p squared. Now we need to find e of x squared. E of x squared will be equals to the summation of x is equals to 0 to infinity x squared times the PMF of the negative binomial distribution. Now follow me through the steps as you saw in the previous exercise. We'll have 0 squared. We'll have the expand squared times the PMF plus the summation of x is equals to 1 to infinity, giving us x squared times the PMF. Now through simplification and forming it into a combination times pause. So when we expand this and we have it in form of a combination times the probability of the successes raised by x and probability of failure raised by r, then we'll be able to expand it in this step where we have the summation of x is equals to 1 to infinity x squared x plus r minus 1 factorial r minus 1 factorial x plus r minus 1 minus r minus 1 factorial p raised by x, and then 1 minus p raised by r. And when we do simple simplification, so that we can take out the common when we move to the next step, we finally see more simplification, which will finally bring us to 1 out of but 1 out of r minus 1 factorial is equals to but 1 out of r factorial will be equals to r out of r factorial. And then p raised by x will be equals to p 1, and then p x is equals to 1. These are the same values. And then 1 minus p raised by r will be the same as 1 minus p when you expand it, r plus 1, and then 1 minus p raised by negative 1. Furthermore, when you input all these things in this equation, then we move to this step and we substitute every one of them in each of the steps. Then we take out the constants. Then we let w is equals to x minus 1, which give x is equals to 1, w is equals to 0, x will be equals to w plus 1, s will be equals to r plus 1, and r will be equals to s minus 1. Further, substitute all these different equations into the formula, which will further lead us into further expansion, which will give us equation 3. But the summation of w is equals to 0 to infinity as a PMF of w and s will be equals to 1, and the summation of w is equals to 0 to infinity w into w plus s minus 1 factorial out of s minus 1 factorial w factorial p raised by w 1 minus p raised by s will be equals to the expected value of w, which will be equals to sp out of 1 minus p. Pause. What is this thing sp? Substituting this into equation 3 that we have will be equals to rp into substitute this equation into equation 3, which will lead us to rp out of r1 minus p into brackets sp out of 1 minus p plus 1. But s is equals to r plus 1, so expected value of x squared will be equals to rp out of 1 minus p squared rp plus 1. Substitute it into equation 1. Variance of x will be equals to expected value of x squared minus the mean value squared, which will give us rp minus substituting the expected value of x squared minus the mean squared will finally through simplification will finally lead us to us finding the variance as rp out of 1 minus p squared. Deviation will be the square root of the variance.